Welcome back, everybody. This is going to be part 1 of 2 in my lecture series on graphing polynomials. In this video, we're going to learn all the tips and tricks we need to know in order to graph them. Let's get started. If we are going to learn how to graph quadratic equations or degree 2 polynomials, we should probably be able to graph degree n polynomials or higher degree polynomials. This big, scary looking thing that I've written down is a general nth degree polynomial. Notice that all polynomials of degree n look like a constant plus something times x to the 1 plus something times x to the 2 plus something times x to the 3, so on and so forth, up to something times x to the n power. A0 through an are what we call the coefficients on each term, but an, the one that is attached to the highest degree term, is what we call the leading coefficient. Quick example, just to get used to this vocab. What is the degree and leading coefficient of this polynomial? Well, the highest power that shows up is 4, so it's degree 4. And the leading coefficient, or LC, is the number being multiplied by that term. Remember, when I don't see anything there, that's a 1, right? So the leading coefficient of this one is 1. One more piece of vocab for you. Suppose C is just some number, is a root of f. Remember, a root is like a 0. So the multiplicity of that root is how many factors of x minus c are found in f. So here's a simple example where I've got a big polynomial already factored out, and I'm being asked to find all of the roots and their multiplicities. I can almost kind of just read the roots off using my zero product property. Again, root is a synonym for a 0. So the roots are 2, -3, and 6. But in order, notice I only have one copy of x minus 2. So the multiplicities, and again, these are in order, are going to be 1, since I just have one factor of x minus 2. I have 2 factors of x plus 3, though. So its multiplicity is going to be 2. And I have 4 copies of x minus 6. So its multiplicity is going to be 4. So why do we care about the multiplicity? Well, the multiplicity of a root is actually going to have some valuable information. Because if the multiplicity is odd, this means that the graph crosses the x-axis at the root. But if it's even, it just bounces off the x-axis. One last tool that we're going to need is what is called the leading coefficient test. So suppose A here is the leading coefficient and n is the degree of the polynomial. When the end behavior can be determined by this chart, right? So I've got it organized in a chart, but you don't necessarily need the chart to remember this information. Because if it is an odd polynomial, one end of the graph is going to go in the opposite direction from the other, right? In both of these cases. When n is even, both ends of the graph are going to go in the same direction. They're either both going to point down or both going to point up. The direction they point is dependent on the sign of the leading coefficient. So if a is negative, we're just looking at the left side. Left side goes down. If a is positive, left side goes up. And again, remember, odd means the right side would go the opposite way. Even means the right side would go the same way. Putting it all together, we start to graph a polynomial by determining its end behavior. Then we find its y-intercepts and roots, and the multiplicity of each root. This information all put together is going to help us sketch the graph. But that's what we're going to do in the next video. In this video, we just looked at all the tools that we're going to need. We looked at how to find roots, how to determine their multiplicity, and how to determine the end behavior of a polynomial. In the next video, we're actually going to put pen to paper and graph some of these. Catch y'all on the next one.